Hello friends, I am Dr. Gurveer Singh from UCET Bikaner, Bikaner Technical University, and the topic of today's lecture is vapor absorption refrigeration system. So let us move forward. What is it? So a vapor compression refrigeration system operates at high grade energy, that is work, which we have already studied in our class lectures, and the vapor absorption type cycle operates on low grade energy, that is heat. So instead of putting in work input, we are giving it or supplying it heat. And the second point which is written here is compressor is replaced with the other components. So we'll see it in the next slide. And the third point is waste heat can be used in vapor absorption refrigeration system. That means that if you are having a waste heat from IC engines, or it may be from solar thermal energy or concentrated solar thermal energy technology, then we can use it very easily in this type of system. So let us talk about the very basic cycle, which is ammonia water based. Here we use two fluids. In vapor compression refrigeration cycle, we are using only one fluid, that is refrigerant, and here the two fluids are, one is refrigerant and another is called the absorbent. So here in this case we are using ammonia as refrigerant and water as absorbent. Now just have a look here. That if we look only the left side portion, just remove this one and put here a compressor, then what is it? It is vapor compression refrigeration cycle. So it operates on this principle that the refrigerant is compressed in the compressor, then it moves through the condenser, rejects heat, then it goes in expansion valve where the temperature is lowered, then it passes through evaporator where it gets heat, and this refrigerant again passes through the compressor and the cycle continues. Now here, in place of a compressor, we are going to use some extra equipments, which are generator, pressure reducing valve, absorber, and a pump. Now there is a question that if we use a compressor and pump, which device will use less work input? Can you answer it? If not, then I'll tell you that we know that work input is given by VdP, where V is the specific volume, and if the specific volume is higher, that means we have to put in a larger work input. So a gas is always having a higher or a larger specific volume than a liquid, and here in this case we are using a liquid. That means instead of using compressor, we are using pump, and we are providing it a less power input. That means it is an energy efficient system. Now let us see how it works. See, first of all, what is the interaction of energy of all these components? This is generator, where we are supplying energy, Qg. This one is condenser, and as usual we know that in condenser there is always the rejection of heat. This one is expansion valve, and in evaporator we are supplying the heat from the storage materials. It may be human being or your fruits or vegetables, milk, etc. In absorber again we are rejecting heat just like condenser. Here there is one more pressure reducing valve, and here there is a pump in which we are giving a very small amount of work input. Now let's see how does it work. Now there are two liquids. First one is NH3 and another one is H2O. In absorber they are contained, and here we are extracting heat out of it towards the atmosphere. Now from here we are pumping this solution through a pump to generator. In generator there is a burner or electrical heating, or it may be solar heating also, in which we are heating this mixture and separating out NH3 vapor from H2O. We are sending this NH3 vapor inside this refrigeration cycle and separating out H2O through pressure reducing valve, and again feeding it back to the absorber. Now forget this part, this is working as usual, and NH3 vapor will pass through condenser where it will condense. Then it will pass through the expansion valve where the temperature will be lower down, and finally it will pass through evaporator and the vapor will enter again in the absorber. So this is the working of the vapor absorption refrigeration system, which is based on ammonia and water as two substances. Now let us move towards the next slide. What will be the COP of this vapor absorption cycle? So COP is, as usual, the desired effect divided by the work input, which is given by the desired effect is refrigeration effect. That means the energy or the heat input which we are supplying at the evaporator. And what is the input? One input we are giving towards inside the generator, and another input which we are giving at the pump. So there are basically two types of inputs. One is heat input and another is work input. But as we know that, and we have already described that pump work is very small than the compressor. So here we can neglect it with respect to the heat, and we can give the formula of COP as refrigeration effect divided by the heat input at the generator side. So this is a figure in which we are showing this vapor absorption system as a thermodynamic system. So here there is a refrigerator which is working between two temperature limits, and Qg is the amount of heat supplied at the generator. Re, or we can also write it as Q evaporator, so we can write it as QE. So Re means refrigeration effect and QE means the heat supplied at the evaporator side. QC is the heat which is rejected to the atmosphere through condenser, and QA is the heat which is rejected at the absorber side to the atmosphere. Now what we are going to do next is, from first law of thermodynamics, using energy balance, we can write the energy balance as the energy entering the refrigerator is equals to the energy leaving the refrigerator, which is Qg plus Re is equals to Qc plus Qa. That is our equation number 1. One more thing, from the second law of thermodynamics, the delta S of universe must be greater than or equals to 0. In ideal case it's equals to 0, and in actual case it will be always increasing. So we can write it like this, that the delta S of the system, or change in entropy of the system, plus the change in entropy of the surroundings is always greater than or equals to 0. Now let's move forward. This is also well known that if a system undergoes a cycle, then the delta S of system is equals to 0. So from the last equation, what is left? Only the delta S of surrounding, which must be greater than 0. Now let us see what is the delta S here. So the first term is from the generation side. Now if you are going to find out the change in entropy in the universe, then you have to take universe as a system. So think you are a universe, or you are a vapor absorption refrigeration system. Then how much amount of heat is leaving through your body? The first one is Qg. Qg is leaving from the universe and is entering towards the vapor absorption refrigeration system. That's why its sign is negative. So the delta S, or the value of S, will be Qg divided by Tg, minus, again, refrigeration effect is also a kind of energy which is leaving from the universe and entering inside the your refrigerator. It will also be negative. Now we are supplying this condenser and absorber energy towards the universe, so there the terms are positive. So now we have a new kind of inequality equation here. So after solving it and simplifying it, we get these results, that the COP must be smaller than or equals to Tg minus T naught divided by Tg into Tr divided by T naught minus Tr, where T naught is the T ambient temperature. For the COP to be maximum, it will be equal to this the product of these two terms. Now let us see what is the product, or what does it convey. Here we can see that we can show this equation as the multiplication of a COP of Carnot cycle or reverse Carnot cycle and efficiency of a Carnot cycle. How? This will be clear from here. What is this? This is an engine which is working between two temperature limits. It is giving a work output. It is rejecting heat to T naught. It is working between Tg and T naught. And there is one refrigerator in which we are giving work input WE. It is extracting heat from evaporator and supplying to the atmosphere. So if we write the COP of Carnot cycle, it will be TE, this is TE, divided by T naught minus TE, which is the Carnot COP of that cycle. Now if we write the efficiency of this engine, the above engine, it will be as Tg minus T naught divided by Tg. So the COP of ideal VARS will be the product of a refrigerator and an engine working on Carnot cycle. Now let us move forward. So until now we have studied about the refrigerator based on NH3 and H2O as refrigerant and absorbent. Now here we are talking about lithium bromide and H2O based vapor absorption refrigeration system, in which we are using lithium bromide as absorbent and water as a refrigerant. The working is almost the same. Here we are having an extra heat exchanger between generator and absorber. The other things will remain same. Here in this figure we can see that the generator and condenser are contained in a single container, and similarly in the another container absorber and evaporator are placed. We can use single container also, double container, triple container as per our requirement. So the working of this absorption system is also the same as we have studied in the NH3 and H2O based VARS. Finally, we are coming to the Electrolux refrigerator. Here instead of using two fluids, we are using three fluids. The third fluid is hydrogen, which is used for the circulation of these refrigerants and absorbents. How? Because we are not using any kind of pump here. Uh, as it is written here also that circulation is due to gravity action only, and we use a burner to supply heat. NH3 easily evaporates in the presence of hydrogen, so this is one of the advantage using H2O in our system. Now the purpose is to eliminate the use of pump in refrigerator and reduce noise. We use hydrogen because it is non-corrosive and insoluble in water. The working remains the same. Here we are having a generator. Then there is a new component for you there. It is a rectifier. Rectifier is used to remove the moisture content from our refrigerant. So here also we are using NH3 as a refrigerant, water as an absorber or absorbent, and hydrogen for the circulation of these two things. So after condenser, NH3 enters in the evaporator here, where there is H2 and NH3, and this mixture enters in the absorber where the NH3 is dissolved in H2O and is removed from here, and H2 again comes out, and at high pressure it is again circulated through the evaporator, and this cycle continues. So this was the working of Electrolux refrigerator. Now let us compare VCRS and VARS. It is very common thing that we supply work to the compression system and heat to the absorption system. Compression systems, however, have a high COP, and absorption systems has unfortunately very low COP, which is currently a maximum of 1.4, which is reported. The performance is very sensitive to evaporator temperature in compression, and in absorption systems performance is not very sensitive to the evaporator temperatures. At the part loads, absorption systems COP does not reduce significantly, whereas in compression systems there is a problem. Liquid at the exit of evaporator may damage the compressor, which is a problem in compression systems. However, this is not found in absorption systems because it is not using any kind of compressor here, and it's also not operating on a very high pressure. Due to compression or using compressor, it has more moving parts, it has to be made more sturdy, uh, and here in absorption system there are very few moving parts, and even zero moving parts we can say if we are talking about Electrolux refrigerator. Of course, if we are using a heavy compressor, then we will have a higher noise and vibration, whereas the absorption system will have a very low noise and vibration. Small systems are compact, and large systems are bulky in compression systems, whereas in absorption systems small systems are bulky and large systems are compact. Compression systems are economical when electricity is available, and absorption systems are economical when we are using a low cost fuel, waste heat, or solar thermal heat. So this was all about our vapor absorption refrigeration system and its comparison with VCRS. So for more details you can drop an email to me at drgurveers@gmail.com. So meet you again in the next lecture. Thank you.